Hello everyone. In this video, we will learn how to apply support vector machine to classify given data set. Let us consider a numerical example. So we have a data points x1, 2, 2, which is being classified as positive. Then x2, 4, 4, which is being classified as positive data. Then x3, 4, 0, which is being classified as negative. So we have two types of data point. Some of the data points are classified as positive and some are classified as negative. So we have 3 points here. Out of this, 2 are classified as positive and 1 is classified as negative. So as per the support vector machine theory, we know that the constraint is summation alpha I yi is equal to 0. So we can use this equation. This is nothing but alpha 1 when you are expanding. So n is equal to 3 because there are 3 data points. So we have alpha 1 y1 plus alpha 2 y2 plus alpha 3 y3 is equal to 0. When you expand this, I is equal to 0, 1 to 3. So what is this y1? Alpha 1. y1 is plus 1. So alpha 1 y1 plus alpha 2 y2, that is plus 1. Then alpha 3 y3. y3 is minus 1, that is equal to 0. So when you simplify this one, you are getting it as alpha 3 is equal to alpha 1 plus alpha 2. You got this equation. So what is the dual objective for this SVM? We already know that L, this is the Lagrangian function. So L alpha is equal to summation alpha I minus half this summation alpha I alpha j yi yj is xi dot xj. So this is the equation, generalized equation. So here we know that I is from 1 to 3. 1 to 3. So substitute here we have, when we are substituting summation for the first term, we will be getting alpha 1 plus alpha 2 plus alpha 3. So as you can see that this is the first part, this part. So you have 3 alphas, alpha 1 plus alpha 2 plus alpha 3. To simplify this, what we do is we can substitute instead of considering 3 variables, we can make it alpha 3 is equal to alpha 1 plus alpha 2. That we already have got it here, this one. This is the equation. So alpha 3, what we are doing is, here instead of alpha 3, we will be substituting alpha 1 plus alpha 2. So we will be getting it as alpha 1, the first term is alpha 1, then plus alpha 2, then plus alpha 3. Instead of alpha 3, we are substituting it as alpha 1 plus alpha 2 minus this complete part we are now representing, simply taking it as q just for simplification purpose. So it is minus half into q. So this is alpha 1 plus alpha 2 plus alpha 1 plus alpha 2. So 2 into alpha 1 plus alpha 2, because 2 alpha 1 plus 2 alpha 2 minus half q. So this is the equation you are getting here. Now what is the next step? So now we have to compute this ones, because we have taken this q, because we have simplified this. So q is nothing but this one. So we have to consider this separately. So q is this one. So what is that one? Alpha I alpha j yi yj xi dot xj. So here when you are, see, this is for alpha I is equal to 1 to 3. So for each alpha value, for I is equal to 1, you have to find for j is equal to 1, 2, 3. Similarly for I is equal to 2, j 1, 2, 3. Then I is equal to 3, j 1, 2, 3. So when you expand this one, for one example I'll show you. Let us consider I is equal to 1 and j is equal to 1. So we'll be getting alpha 1 y1 into x1 dot x1. That will be our first, this case for j is equal to 1 plus j is equal to 2. So it becomes alpha 1 alpha 2 y1 y2 into x1 dot x2 plus j is equal to 3. So it becomes alpha 1 alpha 3 y1 y3 x1 dot x3. Again, now we have more terms there. Now this is I is equal to 1 is over. Now I is equal to 2. So this becomes alpha 2, alpha 1, j is equal to 1. Then alpha y2, y1, x2 dot x1 plus etc. So you have to complete this equation by substituting also. When you substitute this one, all those, when you expand this, you will be getting this equation plus etc. You have to substitute, find this again, I is equal to 3. So we can see that we have the terms like x1 dot x1, x1 dot x1, then we have x1 dot x2, x1 dot x3, x2 dot x1. So we are finding it separately. x1 dot x1 we already found it, x2 dot x2 we found it, x3 dot x3 we found it, then x1 dot x2 also we found, x1 dot x3 also we found, x2 dot x3 also we found. So how will you find that? What is it? x1 is we'll just see, x1 is 2 comma 2, x1 is, I'll just show one example, x1 is 2 comma 2, then x2 is 4 comma 4, 4 comma 4, x3 is 4 comma 0, 4 comma 0. So how will you find x1 dot x1 dot x1? That is equal to 2 comma 2 dot 2 comma 2. So that is nothing but 2 into this 2 plus 2 into 2. So 2 into 2 plus 2 into 2. So you are getting it as 8. Similarly, I'll show for x2 into x2, that you can easily. Now I'll show x1 dot x2. How will you find it? x1 we know it is 2 comma 2 dot x2 is 4 comma 4. Will you find 2 into 4 plus 2 into 4? So this is nothing but 2 into 4 plus 2 into 4. That is equal to 8 plus 8, 16 you will be getting. So similarly, x1, one more I'll show you, x1 dot x3, that is equal to 2 comma 2 dot x3 is 4 comma 0. So 2 into 4 plus 2 into, that is equal to 2 into 4 plus 2 into 0, that is equal to 8. So this is how you find all the dot products. So when you are expanding this, you will be getting some equation like this and substituting the values. So you can easily substitute the values there. So here Q has become like this equation. So after you found all those values, you substitute all the dot products there, you will be getting this one. And when you are simplifying this, you will be getting an equation like this. Q is equal to 8 alpha 1 square plus 32 alpha 2 square plus 16 alpha 3 square plus 32 alpha 1 alpha 2 minus 16 alpha 1 alpha 3 minus 32 alpha 2 alpha 3. So this is what you are getting after simplification and substituting the values for the dot products. So now we, in the first step, we have found that alpha 3 is here. In this equation you can see there are three variables, alpha 1, alpha 2 and alpha 3. But in the first equation we already found that alpha 3 is alpha 1 plus alpha 2. So we can substitute it there. So we are substituting alpha 3 is equal to alpha 1 plus alpha 2 in the previous equation, this equation for Q. This equation for Q we are substituting. So when you are substituting it and expanding it, we'll be getting the equations like this. So here this is the final equation. After substituting everything, you'll be getting like this. Substituting means you already have alpha 1, alpha 2, this values. Here you can substitute this one, 8 alpha 1 square. So alpha 1 square, the terms we have collected together in this one. So you can directly substitute, you can directly expand it and simplify it. You will be getting a simplified equation like this, 8 alpha 1 square plus 16 alpha 2 square plus 16 alpha 1 alpha 2. So now you have to substitute it back to the original equation. What is our original equation? This is our original equation. So this is basically this equation. So L alpha 1 alpha 2 is 2 alpha 1 alpha 2 plus half q. So this q part we have found it now. So you can substitute that q there. So now we are substituting that q here. This is the q part. We have substituted it into that equation. So you got an equation like this in terms of alpha 1 and alpha 2. So we found the Lagrangian dual objective. We got it. Now what we have to do for optimizing that one, we can take the partial derivative with respect to each variable. So we have alpha 1 and alpha 2. So substitute, you take the partial derivative with respect to alpha 1 first. So this equation, this is the equation we are taking with respect to alpha 1. So when you are taking a dou L by here itself, I'll take dou L by dou alpha 1. That is equal to, so the first one is 2, alpha 1 is constant, plus 2 alpha 2, that is, since it's a partial derivative, this term becomes 0. Then we'll be having, so plus 0 minus, this is 8 alpha 1. Then this also becomes 0, 8 alpha 2 also becomes, alpha 2 square becomes 0, minus 8 alpha 2. So this is what you are getting, dou L by dou alpha 1. 2 minus 8 alpha 1 minus 8 alpha 2. That is what we got here. So dou L by dou alpha 2 also similarly you have to find. So the first term becomes 0, second term becomes 2, minus 4 alpha 1 square becomes 0, minus 16 alpha 2 minus 8 alpha 1. So that is the second one. So here that also we got it. Now we have to equate this to 0. So both the equations equated to 0, we'll be getting two equations. One is alpha 1 plus alpha 2 is equal to 1 by 4. And the second equation is alpha 1 plus 2 alpha 2 is equal to 1 by 4. So you got two simultaneous equation. We can solve for alpha 1 and alpha 2. So solving, we got alpha 1 is equal to 1 by 4 and alpha 2 is equal to 0. And alpha 3, we already know that it is alpha 1 plus alpha 2. That also we found it. So we got the values for alpha 1, alpha 2 and alpha 3. Now we have to compute the values for W and B. So the equation for finding W, we already know that it is alpha I, yi, xi. So this is the equation for W. So alpha 1, so here alpha I is equal to 1 to 3. So you have to find alpha 1, y1, x1 plus alpha 2, y2, x2 plus alpha 3, y3, x3 when you take this summation. So alpha 1, you substitute it, alpha 1, y1 also we know, x1 also we know. So this is alpha 1, y1, x1, this is alpha 2, y2, x2. X2 is, I think it is 0. So alpha 2 is 0. So alpha 2 is 0. So we don't have that term. This is alpha 3. Sorry, this is alpha 3. This is alpha 3. Then this is y3. This is x3. So this term is 0 because alpha 2 is 0. So this term becomes 0. So you have only two terms. So you substituted it there. So you will be simplifying, you will be getting it as minus 0.5, 0.5. So you got W as this one. Now let us consider this equation. We have this equation, y1 is w x1 plus b is equal to 1. So this is the support vector. We are just taking it as x1. So we can substitute it this in this one. So y1, this is y1 and this is w dot x1, this is x1 plus b is equal to 1. So we are substituting this, just any support vector we can take. We have chosen support vector x1. So we are substituting it plus b is equal to 1. So when simplifying it, we can solve for b. So we got b as 1. So when you are substituting here, this one is 0.5. The equation is now this is sign wx plus b, w into x plus b is equal to 0. So we are substituting that w x1, this is w plus b is equal to 0. So this is our equation, and when you are simplifying, you just remove the fraction by multiplying with 2. We are getting it as x2 minus x1 plus 2 is equal to 0. This is nothing but this is the equation for hyperplane. So we can plot it. This is the equation for hyperplane. This is the hyperplane. Plotting the equation, we are getting this as the hyperplane, and this these are the original data points, this blue and red. So this one represents our optimal hyperplane. So this is optimal hyperplane. Let us consider another example. So here this many points are given, data points are given, which is positively labeled, and this data points are negatively labeled data points. So we can just plot it into a graph. So when you're plotting it into the two-dimensional space, you can see here this are positive labeled data. This side blue color one are positive labeled, and this one are negative, left side one are negatively labeled data points. So when you see this points, this 3 1, this one, then this 3 minus 1, and this points are very close to the, there can be an optimal hyperplane somewhere here. So we can see these are the data points which are very closer to the hyperplane. So these points are support vectors for this particular problem. So we have identified the support vectors 1 0, 3 1 and 3 minus 1 are the support vectors. Now what we have to do is we can actually augment each support vector with a bias 1. That is for simplification of the combining and simplifying the problem. We can do in this way also. So each support vector we are augmenting with a bias 1. So support vector, first one is 1 0. We are augmenting with a value 1. Second support vector 3 comma 1. Again we are augmenting with a value 1. So support vector 3, that is 3 comma minus 1, we are augmenting with a value 1. These are all bias values. So we are representing, after adding bias, we are representing it as S1 tilde, S2 tilde and S3 tilde. So this support vectors we can substitute into the constraint equation. So when you are adding it into the constraint equation, we'll be getting the equations like this, that is alpha 1 S1 tilde dot S1 tilde dot alpha 2 S2 tilde dot S2 tilde dot S1 tilde plus alpha 3 into S3 tilde dot S1 tilde. You can see that S1 is common here in this particular equation. So S1 is a negative class. So we have to put it as minus 1 here, is equal to minus 1. The second equation is alpha 1 S1 tilde into S2 tilde plus alpha 2 S2 tilde into S2 tilde plus alpha 3 S3 tilde into dot S2 tilde. That is equal to plus 1, because you can see here S2 is common in this equation. All the parts you can see. So S2 is belongs to a positive class. So you are putting it as plus 1. Now the third equation we have alpha 1 S1 tilde dot S3 tilde plus alpha 2 S2 tilde dot S3 tilde plus alpha 3 S3 tilde dot S3 tilde. You can see here S3 tilde is common here and S3 is a positive class. So you had given it as plus 1. So these are the three equations that we got. Now we already have this S1 tilde value here. This is S1 tilde, this is S2 tilde, this is S3 tilde. Just substitute it in this equation. Right now we don't know the values for alpha 1, alpha 2, alpha 3, but remaining all values we know. So substituting for S1, S2 and S3 tilde, you are getting it as alpha 1 into, this is S1 tilde, this values we have substituted it here. So the first one, here it is S1 tilde, S1 tilde, this is S2 tilde, S1, this is S3, S1. So that is equal to minus 1. So we have substituted in all three equations. This is first equation, this is second equation, this is third equation. And simplifying, this is a dot product, as you know that it is 1 into 1 plus 0 into 0 plus 1 into 1. So you are getting it as alpha 1 into 1 plus 0 plus 1 plus alpha 2 into 3 into 1 plus 1 into 0 plus 1 into 1. So you got it like this, plus alpha 3 into this 3 into 1 plus minus 1 into 0 plus 1 into 1. So you got it as 3 minus 0 plus 1, that is equal to minus 1. Similarly for the remaining two equations, so we got simplified and we got three equations like this. So now when you are adding this one, you are getting the equation as 2 alpha 1. Here this becomes 2, this is 4, this is 3 plus 1, 4. So the first equation becomes 2 alpha 1 plus 4 alpha 2 plus 4 alpha 3. So you got 2 alpha 1 plus 4 alpha 2 plus 4 alpha 3 is equal to minus 1. Similarly, second equation you got it as 4 alpha 1 plus 11 alpha 2 plus 9 alpha 3 is equal to 1. Third equation you are getting it as 4 alpha 1 plus 9 alpha 2 plus 11 alpha 3 is equal to 1. So this three simultaneous equations we have. Now we can solve for alpha 1, alpha 2 and alpha 3. So by solving we got alpha 1 is equal to minus 3.5, alpha 2 is equal to 0.75, alpha 3 is equal to 0.75. So for finding the hyperplane, this is the equation we have, that is W tilde. Now we have made it as S, we have made it as S tilde. So W also changed to W tilde. So W tilde is equal to summation I alpha I S I tilde. So alpha I, so here it becomes alpha 1 S1 tilde plus alpha 2 S2 tilde plus alpha 3 S3 tilde. So this one becomes like that, summation. So we have I is equal to 1 to 3. So alpha 1 is minus 3.5 and S1 tilde we have this 101 and plus S2 alpha 2, that is 0.75 into S2 tilde is this one, then plus alpha 3 is 0.75 into S3 tilde. So when you are simplifying this, you got these values 1, 0 and minus 2. Out of this you can see that the last term that initially we have added a bias term. So this minus 2 represents the bias. So the last entry in this W is nothing but it is the offset B. So basically our equation of hyperplane is Y is equal to WX plus B. And this W is here from this one we got 1, 0, 1, 0, minus 2. So this last term represents B. So this represents W. So that is why W is this one and B is equal to a minus 2. So we can again plot this one, B is equal to minus 2, and this one when we are plotting it, we are getting the hyperplane WX plus B. So here this is the hyperplane and this is the final. You can see that the data are classified, those are classified here. So this is how we'll be solving, you will be classifying the data points by means of SVM. Hope you understood. Thank you all. Please subscribe for more updates. Thank you all.